In this session, we are going to discuss an experiment, and it is called double slit experiment. And this experiment was done by scientist called Thomas Young. That's why this experiment is called Young's double slit experiment, which is a very famous experiment in the phenomenon of light called interference. So whatever we discussed about interference, that concept was applied by Thomas Young for the light wave. That's why he discovered the interference of two light waves. We already know about interference. Interference means when two light waves, they are having the same amplitude or frequency or zero phase difference, are traveling in the same direction, and if they meet at a point, then such a phenomena is called as a interference. So this phenomena actually discovered by Thomas Young for the light. So he has done some experiment, and which is very famous as Young's double slit experiment. You can also see scientist Thomas Young. And from this experiment, it supported Huygens wave theory. It was again a basis for the Huygens wave theory. He explained this interference phenomena using wave theory of light. So that is why Young's double slit experiment plays a very important role in the discovery of nature of light. So this Thomas Young did a very simple experiment. He took the light from the sun and he made to pass through a screen with the hole. See, you can see on the screen there is a source. Let's imagine this is a sun. From the sun we can get light. So a ray of light made to pass through a slit or an opening in a screen, and that light is made to pass through again two openings. Let us call this as a S1 slit S1. This is a slit S2. So since he using the two slits, his experiment is called as a double slit experiment. So the light coming out of S1 and S2, light coming out of this S1 and S2 are coherent. They are produced from coherent sources of light. Because see, a ray of light is coming out of the single slit, that is split into two. So the wave which are coming out of S1 and S2 are the light which entered there. So it is producing from a single source. That's why these are the waves produced from coherent sources. So these waves are interfering. You can see the number of spherical wavefronts, and they are interfering. So they can interfere constructively or destructively. See, this is where we have to draw a complete line, dark line. Also we should draw a dashed line, but we are not shown here. The dashed line should draw between these dark lines. So the dark lines, these dark wavefronts, represents the crest of a wave, and dotted line, if we draw, they can be called as a trough of a wave. So crest of a one wave interfere with the crest of another wave. If the trough of one wave is interfere with the trough of another wave, then it undergoes, the two light waves undergoes constructive interference. That is why we will get maximum intensity. You can see this is the points at which light underwent constructive interference. So the crest of one wave interfere with crest of another wave. So this is a place where crest of one wave interfere with the trough of another wave. That's why in such places light underwent destructive interference. So the intensity of the light will be minimum. So this is what we can observe in the spectrum. So this pattern, this band of colors can also be called interference pattern. So this is what observed Young on a screen. So he saw alternative bright and dark fringes. See, bright fringe, dark fringe, bright fringe, dark fringe. So this is what observed by Thomas Young from his experiment. So using this, he explained interference of two waves. So also you can tell about the fringe width of these two fringes. So fringe width means the distance between these two bright fringes can be called as fringe width. Or you can also say distance between these two fringe width. These two fringes is called as a fringe width. So this is about fringe width in this interference fringes. And if you saw here, there is a light coming out of S1, or a light wave is coming out of S1, and also there is another light coming out of S2, which are in phase with the light which is coming out of S1. So if they are reaching to this point, let me take this point I am showing on the screen with the cursor, and if they meet at that point, then the distance traveled by the light coming out of S1 and S2 will be different. That's why they will have some constant path difference. Okay, they will have constant path difference. The path difference between these two will not change. The value will be same. Okay, then it undergo constructive interference. If you take the point at the center, if I take the point at this, the distance from S1 to this point and S2 to this point will be same. So there will be no difference in the path traveled by the light from S1 to this point and S2 to this point. That's why at this point we will get maximum intensity of light. So that's why whatever the fringes we are getting at the center can be called as a central bright fringe. That's why bright fringe central is formed at the center. So that's why that fringe is called as a central bright fringe. So central bright fringe will form here. Why? Because the path difference between these two waves are 0. So if we take any other point other than this point, they will have a constant path difference. So this is what we can understand from the Young's double slit experiment. So using this experiment, we can also determine what will be the fringe width between the fringes. So fringe width means it is a distance between the two consecutive bright fringes, any two bright fringes or any two dark fringes. So this is about fringe width. You can also see how Thomas Young's experiment was done by him. See, you can see a candle, and the light from the candle is passed through a single slit, which will produce as the spherical wavefront. That spherical wavefront is made to pass through again two slits. That's why this experiment is called as a double slit experiment. After passing through these two double slits, again these two waves are interfere over here. They will interfere constructively and destructively, and you can see some bright regions over here, as well as you can see dark region. So wherever we are getting the bright region where two waves underwent constructive interference, wherever you can see black region, this indicates that where two waves underwent destructive interference. You can also see how constructive, interference fringe will appear on the screen. So this is how we can see interference fringes. So this is about Thomas Young's double slit experiment.